Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this Techstrong learning experience brought to you by AWS and Tetrate. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting panel ahead. Before we get things kicked off, we do have just a couple of housekeeping notes I'd like to review. First, today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch or maybe share with a friend. The on-demand recording will be made available shortly after we conclude this live session today. If you'd like to engage with our panelists today, there are a couple of options for you to do so. First option is the chat tab, which can be found on the right side of your screen. I'd like you to go ahead and start testing out that chat tab functionality by letting us know from where in the world you are joining us. I know we have a global audience. We want to get a sense on where everyone is from. If you have any questions, however, we do want you to direct those to the Q&A tab, which can be found directly to the right of that chat tab. Sending your questions to that Q&A just helps us keep track and makes us holds us more accountable to get to your questions. And of course, before we close out, we will be giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program today. So our topic is introducing Tetrate Service Express, a resilient and secure service mesh on Amazon EKS and Tetrate Service Express. And I'm joined by Owen Garrett, Product Manager at Tetrate, Peter McAllister, Partner Engineer at Tetrate, and Saptak Sen, Vice President of Ecosystem and Partner Integration at Tetrate. So Owen, Peter, and Saptak, thank you all so much for joining me today. Saptak, do you want to get this talk rolling?
Sure. So as Jared said, I lead the ecosystem and the partner integration at Tetrate. But before joining Tetrate, I was at AWS. I was part of the team that launched EKS. We work really closely with the EKS team. So a little bit before we get started, a little bit about us, Tetrate. So we are a company which was founded in 2018 by some of the leaders in the cloud native computing community. Varun, who's our CEO and co-founder, while he was at Google, he's also the co-creator of gRPC, which is the underlying protocol for various cloud native communication, and then also for Istio. He was one of the first PMs on the Istio team. JJ, he's another co-founder and the CTO. He was the chair of the CNCF SIG security, as well as he ran the platform team at Twitter. And that's where the genesis of the Envoy project was. Zach was the founding engineer. Again, he also was one of the first engineers to start working on Istio. Matt Klein, he's very, very well known in the community again. He works for Lyft. And as you know, Lyft is the company, primarily behind Envoy. And Matt Klein led the charge, and he's one of our advisors. Sheng is again the creator of the project open source project Apache Skywalking. Adrian is the creator of the project Was Zero for a WASM runtime, essentially. So in short, and this is not the entire list, but in short, we have quite a few people who have had a lot of experience in scaling infrastructure at really large organizations. Now, coming back to our current company, we also work really closely with the various federal departments. One of the organizations we work closely with is NIST. Now, NIST, as you know, is a standards body in the government, and it sets various standards. And we collaborated with them to co-author several standards for microservices security. One of them is NIST SP 800-204 that we co-authored, and various federal agencies as well as commercial entities like financial services companies embrace this standards, right? Yeah. And then we are one of the large contributors or top contributors to Istio and Envoy project. But it's not just that. We also built Tetrate Service Bridge and Tetrate Istio distribution, which are enterprise-ready products on top of open source Istio and Envoy. And we are going to discuss more about Tetrate Service Bridge, Istio distribution, and the new product we just launched. Owen, the product manager for Tetrate Service Express, is going to deep dive on that. So with that, as I was alluding, that we have a very strong partnership with AWS. Here is a quote from Deepak Singh, who's the VP of Compute Service at AWS. In his org, he has EKS, ECS, Fargate, serverless, open source, AWS open source teams, and so on and so forth. From at AWS, we are very aligned from top to bottom. We work with the service teams directly. We provide very early feedback to any of their launches. We have been launch partners for AWS Cloud Map, EKS, EKS Fargate, EKS Anywhere, ECS Anywhere, Container Marketplace, Blueprints, EKS Blueprints, and EKS add-ons, and we continue to work closely with them every day. Now, one launch we did at last reInvent is Istio add-on for EKS. Now, this is directly integrated in the EKS console. And we got a shout out and a demo at the reInvent keynote sessions, where you can very easily deploy Istio directly from the EKS console on your EKS clusters. Not just that, you can also add EKS if you already have an existing cluster, or you can also, if you are using the command line, you can do the same. Here are some links. We'll share the deck later on. Feel free to explore this add-on. It's a good way to evaluate Istio and get started with that. Now, I know I've talked about several of our products, but to lay the ground as to how these differ from each other. So we have Tetrate Istio subscription, which is basically a support subscription on Tetrate Istio distribution. What that means is that you, as a customer, if you are going to production, you get enterprise support, 24/7 enterprise follow the sun support. You also get FIPS validated bits. This is very important for many of our customers who are pursuing various things like FedRAMP. If you're wanting to run on Graviton, again, Tetrate Istio distribution is Graviton ready, and so is Tetrate Service Bridge. So essentially, you build your own management plane, and you own the control plane, but we provide 24/7 enterprise support around that. And this is for customers who are already using Istio or just starting with Istio. And then moving on to the right-hand side, which is Tetrate Service Bridge. Now, this provides a management plane on top of your many control planes that you might have with Istio. In a large organization that we work with, customers such as Visa or federal departments, large federal departments, they won't have a single control plane. They'll have multiple control planes. And do they ensure the consistency of policies, security, and routing of traffic across these various environments, right? So that's what Tetrate Service Bridge provides: a central way to manage, monitor, and enforce control in a multi-tenant way in a very large organization. Now, Tetrate Service Express is what we just announced and we are launching. So I won't steal the thunder from Owen. I'll let him do a deep dive on Tetrate Service Express. With that, I hand it over to Owen. Owen, take it away.
Brilliant. Okay, folks, thank you very much. Saptac, thank you for the introduction. And apologies, I had a bit of a rush at the start to sort out some network problems, so I missed the round of introductions. It's lovely to be talking to you today. My name's Owen Garrett. I help on the product team here at Tetrate. And I would like to talk to you today about a new product that we're bringing to market called Tetrate Service Express. Service Express is based on the foundation of Tetrate Service Bridge that Saptac explained. So although it's a new product, it's built on very, very firm rocks. And Service Express is optimized for users who are looking to deploy applications from Amazon EKS. They're using a service mesh, almost certainly Istio, and they're beginning to wonder, how do they move from one Istio cluster or a small scale deployment to a large scale deployment? And how do they deal with all of the attendant problems that entails? So there are a number of challenges and risks that organizations face. We at Tetrate have spent many years working with Istio and working with people doing production deployments. And we've seen a lot of challenges as organizations have tried to scale. How do they manage to achieve high availability across zones? There are some techniques that the Istio project recommends, but for a very smooth experience across multiple Amazon clusters and regions and zones, then it's difficult to know what's the best practice configuration. Implementing zero trust security, providing access to external teams and external users to services that are running inside your mesh. And most importantly, when you do your first mesh deployments, you're probably doing that under the direction of your employer and employing organization, who are looking to see whether this new technology can bring the benefits that it purports. So how can you deploy mesh, deploy applications, and show quickly and fast that you can bring the benefits that it promises within the time and the budget that you have available? If you get it wrong, there are many risks. Each Istio environment could operate as an island and sprawl. When you try and establish common techniques and patterns and protocols, then there's a risk of shadow IT, as every team tries to do it their own way. There are multiple open source projects that need to be pieced together and a high cost in integrating these. And what we have seen as we've talked to early Istio adopters who've tried to face this problem is that they end up with some difficult situations. They end up with Istio deployments operating as islands with poor consistency, limited observability across all of these islands, a poor understanding of what could be best practice, resulting in a configuration that could be resource heavy, it could be insecure, it could be inefficient in a variety of ways. Difficulty in trying to automate and create a good developer experience for applications that get pushed onto these Istio-based platforms. and unreliable and overly complex intra-cluster connectivity for HA or connecting apps to apps running in remote clusters. These are all problems that we have solved with our Tetrate Service Bridge product over the last few years, and I'm delighted that we're able to bring this together and create a product that is targeted specifically for Amazon EKS users to bring these benefits. How does this product fit together? What's our approach to taming service meshes running on EKS? It comes down to a scalable, secure architecture to provide a management plane and control plane that unifies the configuration and the operation of your Istio-based meshes. I'm sure everyone in this webinar will be familiar with the classic Istio architecture, sidecars embedded within each service, providing control for ingress and egress traffic from that service, ingress and egress controllers, proxies, running at the edge of the cluster, managing traffic in and out, and everything being coordinated by a local Istio-D control plane. The job of Istio-D to take the intent of the administrator and the current state of the cluster and reconcile these into configuration that can then be deployed and managed on each individual sidecar, ingress, or egress proxy. And with this, the Istio control plane does a great job of providing local control to implement authentication and routing, to gather metrics which can then be exported to third-party tools, to configure the certificates and the mutual TLS parameters to secure traffic between different workloads, and to generate, distribute, and reconcile this configuration in real time, so that if changes happen within the cluster, new services are deployed, or outlier detection detects that something has failed, then the cluster mesh network can very quickly be updated so that there's minimal interruption to service. This is a great solution for security, for control, and for observability of microservices-based applications running on Kubernetes on EKS from a local perspective. But as we've discussed, the challenge comes when you try and scale this across multiple individual clusters and to link those together. Here at Tetrate, we've developed a global control plane that is able to monitor and manage multiple EKS clusters and manage the Istio control planes running on each of those. And with this control plane, we're able to reconcile and manage the configuration across all of these individual instances. We can perform service discovery and manage a service registry that is global, that understands everything that's running in each of your clusters, and can then configure the networking layer, the proxy layer, to provide cross-cluster communication and to implement failover between clusters in the event of one or more services going offline. Distribute configuration, not just synchronously to each local control plane, but truly asynchronously, so that we have an architecture that is resistant to intolerant defaults and quickly recovers to a known good state when failed services or clusters return back. Centralized cluster status reporting, so that that can drive both our configuration management and distribution, but the reporting that we provide upstream. And other capabilities that you would expect within a control plane to ensure the correct and consistent operation of your individual clusters. A control plane on its own is of limited use without the ability to define the configuration, the intent that you want, and then to apply that configuration across the individual instances. And so our management plane, the Tetrate Service Express management plane, provides that capability. A single pane of glass that you can access through the user interface, through an API, to can define your intents, to monitor the state, to pull out metrics, to pull out debugging and observability information. The capability to configure your Istio control planes to operate as API gateways, as ingress gateways, as egress gateways, and to manage the intent for cross-cluster communication with security first in mind. Operate workflows, present a consistent service inventory, surface the metrics using Apache Skywalking embedded within TSE or exported to external tools such as Amazon's Managed Grafana. To support audit logging and a rich hierarchical configuration so that your teams are able to configure and manage the components that their applications require. When we put all of this technology together, we're able to meet the needs of modern enterprises and the architecture of applications that they wish to deploy. No longer are they looking to deploy monolithic applications running in a single point of presence with a fixed load balancer and gateway sitting in front, but rather the modern enterprise architecture needs to support security, both internal to the application and for external traffic coming in. It needs to support connectivity, allowing one component of the application to talk to another, irrespective of whether that component is local or is remote. The modern blueprint architecture needs to provide observability. Debugging and troubleshooting becomes critical when you run large-scale, highly distributed applications where there are many more potential failure modes. And should a failure happen, the blueprint architecture needs to provide reliability, the ability to implement HA, to deploy redundant components, and to fail traffic across from one to the other. All of these capabilities are of little use if they get in the way of developers. So supporting developer productivity by working with the common tools that a developer uses rather than trying to replace them. By being careful when taking an opinionated approach, taking an opinion that aligns with how an organization wants to work rather than with how perhaps the software provider thinks the organization should work. And by doing all of this, we can help organizations achieve safe releases, controlled, managed releases of new software components into production. This global view, coupled with the surgical ability to configure and manage what's happening on individual clusters, using Istio as the engine to control network traffic and apply the policies, this is what makes up Tetrate Service Express. A schematic like this gives you one view, but if we were to look what TSE really looks like, if we jump in to one of our demo systems here, this is what Tetrate Service Express presents. We have a simple system here. We have 3 clusters running, 2 workload clusters, and in this implementation, a front-end cluster running an edge load balancer to distribute traffic across those workload clusters. We can jump to the dashboard and look at the topology of our application. We can see what's happening on our tier 1 cluster with the gateway accepting traffic from outside, how that is routing traffic to our 2 workload traffic clusters. And we can jump in. And as we'll see, as we go through some demos later on, we can pull out a lot of detailed metrics on what is happening, how these services are secured, who's accessing them, the kind of traces and logs that you need in order to fully debug and understand what's going on. So TSE gives you a very compelling single pane of glass, but also allows you to build an open, standards-based developer platform where developers can continue to use the tools, the APIs, the interfaces, and the best practices that they're accustomed to in order to get applications into production. With Tetrate Service Express, you no longer have the maze, the confusion, the hubris of multiple different Istio clusters, potentially running different configuration, different software versions, different security standards, the constant challenge of trying to reconcile and understand and secure that. With Tetrate Service Express, you have the ability to consistently and automatically manage, connect and secure the services that you are deploying within and across each of your EKS clusters. So let's go through in a little bit more detail and understand what TSE can do for us. We'll look at it in terms of setup, of security. We'll look at some cross-cluster communications. We'll change some configuration and see what goes on. And we'll look at the observability and the telemetry that TSE is able to build. Let's begin. Let's with a fresh install with a couple of instances running. So if we jump in here. So here I have a simple system with a couple of clusters running. From the TSE interface, I can see what is present on each individual cluster. My first cluster has an ingress gateway and the book info application. The second cluster, I think, is probably almost empty. Oops. So, yep, a simple application and very little else. Tetrate Service Express is straightforward to install. The management plane that we're looking at, GUI and API driven, is installed and deployed by each individual user. It's not a hosted service. It's not a SaaS-based platform. Users of TSE get full control over where and how they deploy their management plane and the security configurations that they wrap around that. Once the management plane, so this console here, is installed, getting started is really straightforward. You can onboard clusters. So we'll talk through exactly the process that you need in order to onboard a cluster, and then the Helm chart, the Helm install instructions that you need to do to follow that. Steps for deploying applications, for creating TSE configuration, for exposing applications. We walk through all of this to help our users become productive as quickly as possible. Now we've got to the point where we have a series of clusters running. I'll delete the stub cluster that we installed as part of the demo just a moment ago. And we can look at various ways that you can configure Istio from within TSE. One of the first things that you might want to look at is how you can set up security and enforce a secure environment in your Istio clusters. Tetrate, as Saptap explained, works very closely with standards bodies like NIST to help develop and implement secure standards to apply policies and approaches such as zero trust. Zero trust is a critical capability for modern applications. Let's talk about what it means in practice. We have a Kubernetes cluster, an EKS cluster. We have a number of services running inside that cluster, happily talking to each other. The premise of zero trust is that the threats to our services no longer are limited to the perimeter, to external users trying to break in to our application through edge devices and edge firewalls. Threats can come just as easily from internal bad actors. It could be an internal employee. It could be someone who has compromised a pipeline and injected some code and a command and control system into the application. But the general philosophy is for zero trust that you have to assume that the local network is potentially compromised, that a user could be present on the local network and looking to use that as a jumping off point in order to intercept, to compromise, to exfiltrate information from your applications. How do we protect against such potential bad actors? This is where the philosophy of zero trust comes in. The very first thing that we can do with TSE is to turn on mutual TLS everywhere. By default, Istio allows both MTLS and plain text traffic. By enforcing mutual TLS, we can require that every single managed cluster can only talk, its workloads can only communicate using authenticated MTLS connections. immediately locking out any bad actors who are sitting outside the mesh and who would otherwise have to obtain access to the certificate authority and potentially try and mint their own certificate or find a much more complex way of getting into applications. So by enforcing MTLS as a first step, we immediately make a big step forwards towards the security of our apps. The next thing that we might do, I shan't do it here because this takes a little bit of work, as we shall see, but the next thing we can do is to set a deny all by default posture for our apps. With a deny all by default posture, if you look at the communication flow that you find between different applications, a deny all posture is an effective way of trying to limit the traffic so that only authorized desired flows are permitted. With the deny all background, then, components can't talk to other components in a way that's not expected. This limits the potential for lateral dispersion. If an attacker manages to compromise one component within an application, it becomes more difficult for him to move laterally to another component unless that has a known and secure communication. By turning on deny all, we immediately set a no traffic allowed policy across all of our service meshes. This is a fairly drastic step, but TSE then allows you to build up a secure set of security policies to allow certain services to talk to each other. And it does it in a way that's very amenable to how your developers operate. The first thing that TSE provides is the concept of workspaces. A workspace is a group of namespaces. It's a place where a developer would deploy a set of services to build up an application. And a very common pattern is to slice the environment into workspaces and allow all traffic within a workspace, making it easy for a developer to deploy an application, at least in a test or staging environment before it's fully locked down, and test the application, knowing that if that application were to be compromised in any way, you could not break out of the workspace. We can then surgically enable individual flows. And these flows are enabled from the perspective of the target service. So as a target service owner, I would declare who is allowed to talk to me. If I'm the authentication service, only certain trusted services can talk to me. This puts control in the right place and it secures that service down, meaning that it's very difficult for other services to reach it. And you can build up your security policies in this way, piece by piece, unlocking individual flows using TSE, reporting through the topology graph and other metrics to understand how this is functioning and to determine that the correct flows are in place. So having set up our network security, we might then look at what's happening to our applications. We looked at the services. We had one cluster running a single app. We had another cluster running the classic book info application. If we look at what that looks like now, and as we let that go, I'm just going to enable book info somewhere else. But here we can see we've got cross-cluster communication. We have cluster 2 with a sleep application here calling our book info application, the product page. Book info is also being accessed through an external service. So with this cross-cluster communication, we're allowing third-party services running in other clusters to talk directly to our cluster using local networking, local names. So from the perspective of this sleep client, it appears that our product page is local, running on the same cluster, using consistent DNS names. This makes it extremely easy to build applications that span multiple clusters. And of course, you can use the security policies we discussed a moment ago to help lock this down and secure it. This capability of cross-cluster communication can also be used in order to achieve high availability. So I just enabled, here we go. So I enabled book info to start running on my second cluster, just as we talked. And if we rearrange this and look at what's happening, Now, TSE has detected that we are running multiple services on multiple clusters. So our sleep service here is still accessing the product page on our cluster 1, but we've also spun up instances of services now on cluster 2. Cluster 1 is beginning to consume those and load balance traffic between both its local instances and its remote instances. Again, with no changes to the application, no intervention or interaction from the developer or even the service owner. This allows you as the platform owner to set up high availability across clusters, knowing then that if an individual service were to fail on the first cluster, traffic will automatically fail over and use the instance of that service running on the second cluster. When you publish a service, so let's come and look at the question of ingress networking. So as we publish a service, TSE can also set up and configure the edge load balancers necessary for users to access the service. TSE is all about automating the operations that a platform owner would typically do. A developer who pushes a service into production can deploy an ingress gateway resource, as we see on the right-hand side, and TSE will automatically enable that ingress gateway rule on a local ingress controller, and additionally set up Amazon load balancing to direct traffic across instances of that ingress controller. And if you as the platform owner have set the capability up, we'll also provision DNS names. You can see we've mentioned a DNS name, bookinfo, TSE, Tetrate labs.io in our ingress gateway request, and automatically TSE has gone and configured that through Route 53. If we look at the hosted zones that I'm managing on my Route 53 platform and look at our Tetrate labs.io, when I span this up, you can see instances like bookinfo were given an A record to point to the load balancer that's sitting in front of the ingress gateways that are delivering our applications. So with TSE, we have control, or we provide control over ingress networking so that the platform that TSE operates can interface and provision DNS records as needed when developers push applications into production. And we also provided control, as we saw, over cross-cluster networking. A developer can deploy their applications to several different clusters, and TSE will automatically stitch together the necessary HA rules for high availability and cross-cluster failover, and the necessary service discovery rules, so that if a client is running on one cluster, it can easily access a service running on a remote cluster without needing any changes in addresses, not needing any service discovery steps other than to use the common DNS name for the target service. TSE provides a host of capabilities to help you understand and diagnose what's happening to traffic. We've seen how we can configure traffic management. Let's have a look at the kind of metrics that we can get. If we look at our bookinfo ingress gateway tool, if we look there, we can pull together a range of metrics showing various latencies, traffic levels, pull out logs from that. The capability that I find most useful when I'm trying to understand the topology of my application, in addition to the dashboard, is the ability to also pull out traces. TSE will sample and collect traces automatically from our applications, storing those locally so that you can then query them interactively, as we're doing now, or offline through a set of tools that we provide where you can export traces and provide them to your development team, for example, should they then wish to go through in more detail and deconstruct them. Here we're seeing an individual request that came in through our ingress gateway to hit the product page for bookinfo and was then distributed to various services. We can pull out discrete timing We can see the duration of the entire request, just under 30 milliseconds, how that was allocated to different services. And with the metrics that TSE provides, we can also determine where time is used. Is time being used over networking? Is it being used in the sidecar? Or is the time actually consumed within the service implementation itself? We can look at things like requests, responses, status codes, so that we can better understand transient or unexpected errors within our applications. So with TSE, you get a powerful central point of visualization of the services that are running in EKS and control over the platform that you've created, so your developers can operate in a productive, secure, easy-to-use fashion. TSE is GitOps ready. You can drive TSE configuration directly from Git, should you wish, so that you can have a full GitOps-powered environment where the necessary TSE configuration is pushed out and consumed by TSE in order to create things such as ingress resources, then rippling through to the DNS records that your services may require. We're building out a suite of integrations with key Amazon services with a view to optimizing the ease of use, the lack of surprise when users deploy and work with TSE. We talked about Route 53 and how we automatically provision DNS records when you deploy an ingress gateway, request an ingress gateway. In a future release, we will automatically support multi-cluster load balancing so that you can use Route 53 to GSLB traffic across multiple EKS clusters. We are using the Amazon Load Balancer controller. The next preview release will have full integration with that, and NLB were available and were not available. So for organizations running in more legacy Amazon environments, falling back to classic load balancer. We have integrations published with Amazon Managed Grafana so that you can export the metrics to a common dashboard that your developers have access to, and with Amazon Private CA, so that should you wish to use PCA or indeed any other external certificate authority rather than the internal CA that TSE manages, you can do so. And with that, you can then mint additional client certificates very easily and provide for secure communication between workloads which are on the TSE managed mesh and workloads without, with many more to come. And our early adopter users are taking this technology and providing some vital feedback as we further refine it to improve the user experience before we hit GA in a month or two's time. If you'd like to get a sneak preview of what is going to come within the TSE product, and we would deeply value your feedback on the product as it stands, the user experience, and help us shape the roadmap, then please find us, sign up for an evaluation, and we'd be delighted to provide you with the software and a very detailed evaluation guide so that you can have a productive time learning and experimenting with TSE, provide us with critical feedback, and determine for yourselves what can you learn from the TSE experience. So with that, I'd like to thank you very much for your time today on today's webinar. I hope that TSB's been I hope this has been a useful experience for you. I'd love to see some of you in our evaluation program when that comes, and I'll take it at a pause and we'll hand over and we'll look and see. I'll hand over to Peter perhaps and see if we have any Q&A or follow-up actions from the webinar.
Owen, great presentation, and I think we were able to demonstrate different parts of TSE, our new offering. Only additional thing I would like to mention that with AWS product also will be available through AWS Marketplace. So we're working on integration right now. In terms of questions we got just one question around security, specifically security incidents and metrics. And in general, how TSE is working it's using skywalking to collect data from all multiple service mesh members, right? So aggregate everything and present as a single view what Owen demonstrated in his demo. We don't really distinguish between security metrics and metrics related to your infrastructure. Additionally to it, there's different types of security incidents and security problems that can happen, and they can happen on different levels. They can happen on your Kubernetes level, on your application level. It can be also permissions or some interesting stuff happening on our platform, right? So all of it is different products, and doing in TSC, we aggregating all these logs and allowing you to search through them. You can search through pod logs, you can search through events that were recorded in different places, right? So, but obviously, depending on security pattern or security attack pattern, it can be in some places where it's not specifically obvious to look for, right? So even we aggregate all information and have it, so you have to do your homework to make sure for a specific incident you get full picture in your environment. I hope it helps. I don't see any other questions, but let me double check.
Yeah, there's a question which came in. Yeah, so there was a question that came in which saying, can we upgrade from TSC to TSB?
Certainly, it's a path that we're going to support. So TSC is an easy way for you to onboard enterprise service mesh with multiple clusters, multiple control planes. If you want to introduce your enterprise security system integrated with WAF and do other things that TSB allows you to do, we are actually in a product itself. It's a built-up ability to move. As soon as you're ready, we will help you to move from TSC to TSB, basically upgrading TSC to TSB. Yeah, so thank you. It's a great question, and it's totally what we're seeing in terms of interacting with customers. Pattern here is I want to start very fast. I want to deploy my enterprise service mesh as promptly as I can, and then I want to move to more advanced system that TSB provides me. Yeah, thank you.
Thank you very much. This has been a great experience chatting with everyone. Please come and find us, tetrate.io. If you'd like to find out more about TSC, we'd be delighted to run either private demos or get you access to the software.
Okay, thank you so much. And from Tetrate, we'd love to thank you for joining. If there are any additional questions, do not hesitate to reach out to us, and we can take it from there. With that, I'll hand it over to Cody.
Owen, Peter, Saptak, thank you all so much for joining me today. Really appreciated having you with us on Techstrong Learning.
Thank you, Cody. As always, pleasure to work with you. Thank you for leading it.
Of course. So just a quick reminder to our audience that this session was recorded. You will be receiving an email with a link to access the recording on demand, or you can also find it living on the Security Boulevard website at securityboulevard.com/webinars, and then be sure to look in the on-demand section where it will be waiting for you. The 4 winners of our $25 Amazon gift card drawing are Nicholas R., Ramakrishna V., Ken P., and Camilo V. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should make its way over to you in about the next 48 hours. But if you don't happen to see that email, check your spam folder just in case it happens to get filtered out. I'd like to thank AWS and Tetrate for sponsoring this program today. And to our audience who is still here with us, thank you so much for being here. We really appreciate your time today, and we want to ask for just one more moment. As soon as we close out, there will be a survey that pops up. Let us know what you thought about this program, or perhaps if you have recommendations for an upcoming program, we would love to hear it. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and Owen, Peter, Saptak, thank you all once more.
Thank you.